This is my tabletop recreation of the game Keep Talking and Nobody Explodes.
3 wires.
3 wires. Are there any red wires?
1 red.
Is the last wire white?
No, it's blue.
How many blue wires are there?
1.
All right, cut the last wire.
My project is just the central unit, as the modules are Daniel Odemelum's project, another ACES student. The design is meant to resemble the bomb from the game as closely as possible, having a compartment for each module with a large PCB underneath for all of them to plug into. There is also a main timer module with the timer, strikes, and other information to be communicated between players, such as the serial number, and a PCB on top with more such information. The game is designed to be unique each time it is played, being able to switch around the amount of modules and adjust the timer, as well as information changing each time. The modules in this game communicate using an inter-integrated circuit bus, or I2C bus, a common close-range communication protocol. The hardware of I2C is simple. Only 2 wires are needed to communicate between devices: SDA, the data line, and SCL, the clock line. SCL provides a constant pulse so that all devices on the bus are synchronized, and SDA is the line for data transfer. There are also 2 types of devices on an I2C bus: controller and peripheral, also called master and slave. The protocol of I2C is essentially a set of rules that all devices with I2C capabilities agree on. Only the controller can initiate communication, and it does so by pulling SDA low while SCL is still high. This signals to all peripherals that the controller has taken control of the bus and can begin transmitting data. So there are 2 types of data sets called frames used for I2C, the address frame and the data frame. The address frame is sent first, and it's 1 byte, with the first 7 bits being the address of the peripheral being addressed. So when SCL comes low, that's when SDA is going to transmit the address byte, and the first 7 bits, it's read most significant bit first. They can be anything. For ease of just drawing here, let's say that it's our 7-bit address. And then there's going to be an 8th bit that tells us whether the controller is reading from the bus or writing to the bus. So let's say it's writing to the bus. I believe that's low. Don't quote me on that. That might be wrong. Right. The clock actually alternates with each bit sent. So I'm not going to draw this. That continues on forever. So there you have bit 1, 2, 3, 4, 5, 6, 7, 8. That's your byte of, that's your address byte, your address frame. And then if the peripheral with this address is there and is receiving this, then it's going to pull the bus high. It's going to send back something called an ACK, or acknowledgement bit. So it's going to pull the bus high, and if it doesn't pull the bus high, then the controller knows to return an error message. So once the address frame has been sent, and the controller knows which peripheral it is sending data to or receiving data from, the peripheral is ready to do that, then the data bytes, or the data frames, will be sent either way. So a data frame just looks like a string of 1s and 0s. So let's say it's after that, the responding device will ACK, or it won't, which is called NAC, which is negative acknowledgement. And there you go. You send as many data frames as you want. And then we have our SCL down here. The clock will also be low. And the stop condition is that the clock goes high and then SDA goes high. It has to follow it. Otherwise, that is not a correct stop condition, and the controller will still have control of the bus. So in this project, I2C is used to send the information found on the central unit by that player to the peripheral modules and receive back data whenever a module is failed or completed by the player with the bomb, the diffuser player. Because only the controller can initiate I2C communication, it instead uses polling. It does a scan at the start of the game, where it just uses an address bit to check, with this ACK whether every possible module address is there or not. And then when it polls, it will go through and see if any of them have an update, whether that may be a strike or a completed module.